Okay, thank you, Julianne, and welcome to the second of a six-part talk on the Museum of Natural History. I don't know about you, but whenever we have people visiting us who are not familiar with Gainesville, a must-do activity is to go to the Butterfly Museum. I think it's one of the highlights of most people's first-time acquaintance with Gainesville. There are other good butterfly museums. There's one in Key West, I know, and there are many butterfly museums, I guess, all across the world. But the one in Gainesville is special, our speaker today, Professor Jaret Daniels, is not only partly responsible for the quality of the museum butterfly exhibits, but has other activities that represent the importance of butterflies and other Lepidoptera in pollinating plants. Dr. Daniels is the curator of the Florida Museum of Natural History McGuire Center, and he's professor in the Department of Entomology and Nematology at UF. An entomologist by training, he specializes in the ecology and conservation of at-risk butterflies and other native pollinators. So without any further ado, let me introduce Professor Daniels.
Thank you, John. Good morning, everybody. I hope that you're having a good Tuesday. It's really a pleasure to be here. As John mentioned, I'm really a deviation of an entomologist. I'm a conservation biologist, so I work primarily with those species that are, really important environmentally and also very charismatic, like butterflies. So I work on a multitude of different taxa across the US and Canada, but today I want to kind of introduce you to particularly things in your landscape or the landscapes around where you live that are particularly important for kind of improving the habitat of many of these really valuable organisms that we see regularly in gardens, we see regularly as we drive along the roadside. Can you hit the spacebar? Thank you. Okay, so before I kind of jump into the world of butterflies, bees, and other pollinating insects, I want to just start with insects in general, because unfortunately insects get a bad rap. They're often vilified as pests and pathogens and vectors of disease and kind of things that we want to eradicate versus preserve and save. And insects and other arthropods are really, if you boil it down, the most diverse components of all terrestrial ecosystems. Hands down, you can barely take a step outdoors without impacting an insect, an ant or other insects. Currently, there are about 1 million species of insects that account for over 80% of all animal life on the planet. And when all said and done, about 5.5 million to an estimated 10 million species of insects probably exist in the greater world around us that have yet to be discovered by scientists. And I love this figure because it gets into the world of zeros associated with the cosmos or other sciences, but at any given time on the planet, there are some 10 quintillion insects alive. So that's a lot of zeros, certainly more zeros than are on my paycheck every week. But it's an amazing world out there with the abundance and diversity of insects. And we also know that insects, beyond the fact that some are arguably pests and vectors of disease, that the majority of insects out there play incredibly beneficial roles in the world around us and benefit our economy, our agriculture, and the number of services they provide are many, and these are only just a few, but if you kind of drill down, pollination is a critical ecosystem service that many, many insects provide. natural pest control. If you grew up as a gardener or have a window box garden or whatever, you know that there are a number of different natural enemy insects that provide natural pest control versus having to break out a can of insecticide. Nutrient recycling, when insects feed on plant material and poop out the other end, that recycles nutrients in the greater system around us. They're critical for decomposition of organic matter, animal waste, carrion, and they're incredibly important as food for other wildlife. So many organisms feed on insects in one life stage or another. So if you're a birder, as an example, you know that when birds are feeding their developing young, great majority of that diet is directly insects, that high protein diet for development of those young birds. So overall, they are incredibly important ecologically and also incredibly important to the world around us and our economy and our food production overall. And if you just look at insect pollination as one key service, conservatively on the planet, over 87.5% of all flowering plants, crop species, ornamental species, native species, rely on animal pollinators to set seed and produce fruit. And the bulk of that service is being delivered by insects. And this affects obviously not just agriculture and food production, but the berries and fruit and seed that other wildlife consume. Maintaining natural and rich and diverse systems like this tall grass prairie, you can make an argument that the seed production for biofuels is really, really important. Rich, diverse forage for cattle and other ruminants. And you can make a really strong argument that without that insect-plant interaction, we wouldn't have the multitude of pharmaceuticals that benefit our lives every day. So all of this kind of stems back to the role of insects in the environment, and particularly as pollinating organisms. And beyond bees, which are the dominant sort of charismatic pollinator that we're all well aware of, and particularly the Western honeybee, which is probably the most economically important insect at a global level, many, many different other insect groups are critical and valuable pollinators. And this includes butterflies, it includes flies, which don't get a lot of respect, but are incredibly diverse and very, very abundant flower visitors. Many beetles also visit flowers and help move pollen from one blossom to another. The whole nocturnal community of moths, which again happens when we're in bed at night, but are very, very important for pollinating and moving pollen from one blossom to another. And then other insects like wasps, which provide not only the service of pollination, but many of those also provide natural pest control as well. So many of these have dual roles in the environment that provide benefit to our well-being on this planet. And then if you just look at agriculture within Florida, and Florida is a very agronomically diverse and rich state, we have over 200 different commodities that are grown in Florida. A bulk of them, of the crop species that you see around us, about half of them rely on insect pollinators exclusively. And if you look kind of generally across the year, an agricultural year, insect pollination just within Florida for the 7 top crops is estimated to be about 50 million per year per crop. And if you do the math and extrapolate from that, the total value of insect pollination per year for Florida agriculture exceeds $1 billion. So that's an incredible benefit to the state, not only in food production, not only in driving our economy, but providing jobs. So you can make a very strong argument that Florida would not be as productive if it wasn't for insects around us. And insects, particularly having a diverse array of different types of pollinating insects and insects in general, adds to the sustainability and resilience of the world around us, the systems that we enjoy, the systems that we rely on for our economy. So whether it be weathering challenges due to overuse of insecticides, climate change, land use change, habitat loss, but just ensuring that we make our land around us more resilient and sustainable. And there's also good evidence that while bees are the dominant and most efficient pollinators, the bulk of the other insects actually make more flower visits than bees collectively. And they're kind of equivalent to the safety net behind bees. So I equate this to a stock portfolio. If you were to invest all your money in one stock and the market tanked, you wouldn't be in a very good situation. But if you have a very diverse portfolio, you can weather those ups and downs. And so that bulk of other insects beyond bees is sort of that ability to weather those ups and downs due to human impact on the planet. And just to think about this from a very charismatic group of insects and pollinators like butterflies, we all agree that these are probably the most attractive insects out there. We actually invite them into our landscapes. Globally, there's about 18,000 species of butterflies, about 750 species in the US. And in Florida, we have the most butterfly species of any state east of the Mississippi. So a great state for butterfly watching, for gardening. I'm sure you see a lot of different butterflies on property here with the gardens that you have around. So a lot can be attracted just in a small area. And if you live, anywhere in Florida, any one single location in Florida, you can reliably see about 65 to 70 different species of butterflies. So that's a pretty good diversity of beautiful organisms to enjoy. But all the news is not good, obviously, with biodiversity and insects overall. And there's been a lot of attention recently, right or wrong, about decline of insects. And some of these headlines are a little bit sensational. The insect apocalypse is here in the New York Times. Science insect decline, robust evidence of insect decline. And undoubtedly this is happening and happening to even very supposedly common organisms like the monarch butterfly that are having very, very poor years. But what we know about insect decline is that, particularly in well-studied groups, bees and butterflies, those declines are going pretty severely downward. And so this is worrisome, not only from a wildlife enjoyment perspective, but because of those ecosystem services that I mentioned earlier, the role that those insects play in the surrounding environment to food production. If they continue to decline, it's at some point going to affect our well-being, our economy, our food production, our food security. So it is inherently tied to the loss of biodiversity. And the solution is not simple, because I actually love this illustration in a scientific journal. It's called Death by 1,000 Cuts, the numerous threats to insects. And it illustrates the fact that not one single threat is sort of driving that decline. Obviously habitat loss is a big one out there, but everything from, changing climate, storm intensity, nitrification, pollution, particularly light pollution as an example, agricultural intensification, overuse of insecticides, all these contribute to sort of cut out the legs of those insect populations. And what that means is that now more than ever, all these different landscapes really matter. No longer can we just rely on wild lands because we know that biodiversity is declining on those wild lands. We have to look to alternate landscapes to try to build back those populations, everything from farmland, urban green space, rights of way, whether it be utility rights of way or roadsides, as opportunities to kind of enhance the resources for these very important insects and kind of build back those populations over time to ensure that we have a very resilient world ahead of us. And there's also a good argument that, scientists love kind of drilling down into the numbers and often overanalyzing things. And there's been a big argument within the scientific community about the slope of those insect declines. But this paper, I like this because it says declines in insect abundance and diversity. We know enough to act now. And its point is the fact that we can argue as scientists all day long about what that decline actually is, but we know that insects are declining. And so what's the harm in taking action to rebuild habitat, to manage landscapes more effectively, to rebuild green space? And if it turns out that those declines are not as severe as we once thought, well, no harm done. We still are building back resources for insects. And so this is what we have to do, is to try to repurpose, to remanage landscapes more effectively, not only just to build back insect populations, but for other wildlife and to create livable spaces where humans and wildlife can coexist and interact. And I want to present now a few examples from different types of landscapes and some of the research that we've done in my lab and other labs at the University of Florida to talk about what is actually possible across these different landscapes. So we'll start with agriculture, because this is obviously a dominant industry in Florida, second only to tourism. And because insects are so critical to the pollination of specialty crops such as blueberry or watermelon or squash, and the list goes on and on. So one way that we can build back populations and resources in agricultural landscapes is potentially make these more opportunistic for insects to enjoy and take advantage of. So if you look at a typical farmscape in the background there, there's a crop of squash being put into the ground there. But if you look around in the background, there's not a lot of resources for insects. There's not a lot of blooming plants. There's not a lot of nesting resources. It's a pretty hostile environment. And yet we're asking insects to come into that environment and help us produce food in a very productive way. So one alternative is that we can turn parts of that landscape into large wildflower meadows, providing a resource of pollen and nectar to draw those insects in, provide nesting resources, an abundance of food, and then hope that they spill their pollination service over onto the target crop in the background. And what we found from research in this context is that if you build it, they really will come, and it makes a significant benefit to pollination services as well as the number of organisms that occupy this particular landscape. So in this context, enhanced margins by planting wildflowers compared to fallow land in the background attract almost 19 times as many pollinating insects as just leaving land unproductive. So farmers, growers can put minimal resources in to make an abundant amount of resources to draw those pollinators in and have real benefit to their target crop. Increase not only the production of food, the symmetry of food, getting food to production and to market sooner. All of this make a crop more kind of consumer worthy, if you will, for the grower. And we also know that diversifying these landscapes from organic farming as a model provides many other benefits. And not only do we attract pollinating insects, but we attract a wide range of other wildlife, including beneficial insects, predatory insects, birds, insectivorous birds into that landscape that provide natural pest control as well. So in theory, you're enhancing your pollination services, you're reducing the use and necessity of insecticides because you have those wild pollinator and beneficial insect populations there as well. So there's multiple benefits to this approach overall for agriculture and even for small home gardens as well. There we go. Sorry. Back. So another landscape that we work on that's, again, front of mind to most people, this is actually the most viewed landscape by most Americans, and this is a roadside. And when I came down, I grew up in Wisconsin, and I used to love roadsides as a kid because roadsides were fantastic places to find insects. They were fantastic places to find rare plants. I grew up in a prairie state of Wisconsin. That's the only place you could really find around my house kind of relic prairie plant communities were along roadsides. So when I came down to Florida in the 1990s, this is what I saw. I visited UF in February, and the roadsides were ablaze with phlox and coreopsis. And I thought, well, this is amazing. This is, glorious to see all these roadsides with an abundance of wildflowers. But when you drive along, you also see this happening a lot. This is Department of Transportation mowing, and mowing is the most frequent management style along roadways, or management to knock down weeds to provide safety for motorists and all that. But the question is, do they have to mow as often as they do? And if you had a guess, how often would you say that they mow in the county of Alachua County on a regular basis? It's every 3 weeks. So that seems like a crazy amount of mowing, right? I mean, it seems like an overuse of resources. It seems like a lot of labor and not a lot of benefit for doing this. So we were very curious in my lab about this. So we worked with the Department of Transportation, which has been a great partner in developing a study that looked at mowing frequency and its effect on blooming plants along roadsides and also the flower visiting insects that were attracted by those blooming plants. So we investigated 3 different mowing frequencies, every 3 weeks, which was the norm in Alachua County, every 6 weeks, twice as much, and then no mow entirely. And we went out, we monitored the blooming plants, recorded the species, we counted blooms, and we passively collected insects to get an idea of what the diversity and abundance of insects utilizing these rights of way were. And what we found, not surprisingly, is that these roadsides, even roadsides within Gainesville city limits, are amazingly diverse. They support over 133 species of flowering plants, tremendous diversity, including many rare plants, abundance of beauty on those roadsides. And this is a great picture of a roadside as you drive out towards Chiefland, ablaze in the fall with helianthus and liatris. And I'd much rather drive along this roadway than a mowed roadside that looks like a lawn. So a lot of diversity here. And we also found that this diversity of blooming plants attracted a huge diversity and abundance of different flower visiting insects, pollinating insects in 11 orders and 147 families. So this shows that if you kind of manage these roadways a little more effectively, they can really be productive. But what we really found, and I apologize for graphs and presentations, but this is the only easy way I could show this, but if you look at every 3 weeks and every 6 weeks, there's a huge disparity there. So by moving from 3 weeks to every 6 weeks, a small change in mowing frequency was equivalent to not mowing at all during the entire year. So small changes by the Department of Transportation, which will not affect public safety, which will lower costs, have very profound effects on the pollinator community of those roadways. And guess what? Roadways run adjacent to or bisect natural lands and agricultural lands. So instead of taking land out of production, as in the previous model, here we can manage roadsides better to ensure that pollinators are using those roadsides and then spill over onto the adjacent agricultural land, providing the same pollination services as planting that wildflower meadow on a grower field. So this is a really good model, in my opinion, of things that can be managed more effectively to enhance all of our lives. And beyond this, we have beautiful roadsides to look at when we drive. There's actually even a small ecotourism industry in Florida for wildflower driving tours. So all of this benefits our economy. All of this benefits the productivity of the state of Florida in general. And finally, the Department of Agriculture in Florida is taking notice of this. This was the cover